Assalamu alaikum, dear students. Our next numerical is related to find out the molecular formula. The problem is related to the molecular formula is that a natural product composed of only carbon, hydrogen and oxygen can be extracted from bark of willow trees and used as a painkiller. A 20.71 gram of sample of compound was analyzed using elemental analysis. Mostly combustion analysis is used. That is only used for organic compounds, specific organic compounds that contain only carbon and hydrogens or oxygen. By combusting it in the excess oxygen to produce 46.20 gram of carbon dioxide and 8.109 gram of water, compound was then analyzed by mass spectrometry and determined to have the molecular mass of 138.1 gram per mole. Calculate the empirical and molecular formula of this compound. First thing, always keep in mind, to calculate the molecular formula we always calculate empirical formula. Okay, an empirical formula contains some steps. First of all, to find out the number of moles of elements in the compounds like carbon, hydrogen and oxygen, then find out the molar ratio, and then we will find out the simplest whole number ratio. That will be the empirical formula. If answer in the fraction, we convert that fractional answer into the whole numbers. Let's go. We calculate this problem step by step. Step number 1. First of all, we calculate the mass of carbon from carbon dioxide. In the problem, mass of carbon dioxide is given, not the mass of element carbon. In other words, mass of carbon is given. From the mass of carbon dioxide, we will first calculate the mass of the carbon. From the mass of carbon, we calculate the moles of carbon dioxide. From mole of carbon dioxide, we will find the mass of carbon. First of all, how we can find out the moles of carbon dioxide from mass of carbon dioxide? We know that number of moles is equal to mass over molar mass. Mass of carbon dioxide is the 46.20 gram and molar mass of carbon dioxide, that is 44 gram. Number of moles of carbon dioxide is 1.05 moles. Multiply these number of moles with the atomic mass of the carbon in the carbon dioxide. In the carbon dioxide, there is only one carbon, and one carbon atomic mass is 12. So 1.05 multiply with 12.6 gram. So mass of carbon in carbon dioxide is 12.6 gram. Okay. Next, we use this mass to calculate the number of moles of carbon. First, we calculate the number of mass of hydrogen from the water. Mass of water is given, same as we solved the previous step. Mass of carbon from mass of water, number of moles of water. From number of moles of water, mass of hydrogen can be calculated. Same formula, number of moles and is equal to mass of water divided by molar mass of water. Mass of water is 8.109 is given in the statement, divided by 18, that is the molar mass of water, that is 0.45 moles. Okay, we know that water have a 2 hydrogen. One hydrogen have atomic mass 1.008 and 2 hydrogen which will have a 2.016 molar mass. Multiply these moles of water with the 2.016 molar mass of hydrogen, then mass of hydrogen is 0.9072 grams. Okay, next we calculate the mass of oxygen. Mass of oxygen can be calculated. We know that oxygen is common in carbon dioxide as well as in the water. So with respect to common elements, we change the formula. Total mass of the compound is given, that is 20.71 gram, and mass of carbon and mass of hydrogen combined is 13.5072 grams. 20.71 minus 13.5 is equal to 7.201 gram. That is the mass of oxygen. We calculated the mass of carbon, mass of hydrogen, and mass of oxygen. Use these masses to calculate the number of moles. Number of moles of carbon, mass of carbon divided by atomic mass of carbon, number of moles of hydrogen, mass of hydrogen divided by atomic mass of hydrogen, and number of moles of oxygen, mass of oxygen divided by atomic mass of oxygen. Number of moles of carbon is 1.05 moles, number of hydrogen 0.9 moles, number of moles of oxygen 0.45 moles. Next we can find out the molar ratio. How we can find out the molar ratio? We divide all the values of number of moles with the smallest value. Smallest value is 0.45 moles. Okay, that is the molar ratio. Carbon have a 2.33 molar ratio, hydrogen have a 2, and oxygen have a 1. If your one of the answer is in fractions, change this fraction into the whole numbers by multiplying with their suitable numbers. Okay, if we multiply 2.33 with the 3, the answer is 7. 7 is the whole number. Similarly, multiply these all molar ratios with 3. Okay, with 3 with respect to carbon, answer is 7. With respect to hydrogen, answer is 6. With respect to oxygen, answer is 3. In the empirical formula is C₇H₆O₃. Okay, we have calculated empirical formula using this empirical formula. Next we find out the molecular formula. To find out the molecular formula, first of all we calculate the empirical formula mass. Okay, empirical formula mass is 138.06 gram per mole, and molecular mass of the compound given in the statement, which was calculated by the mass spectrometry, is 138.06. It's mean empirical formula mass and molecular formula mass are same. Then we find out the ratio of the empirical formula mass and molecular formula mass. Molecular formula mass divided by empirical formula mass is equal to 1. 1 mean we multiply this digit, this ratio, with the empirical formula C₇H₆O₃. It's mean its molecular formula and empirical formula are same. Okay, this formula is the formula of salicylic acids. It's mean pillow trees have a natural product, that is the salicylic acid, that is used as a pain reliever. That's usually known as aspirin, which is used to manufacturing of aspirin. Okay, I think you got all my points related to this numerical. There is an other method to solve this problem. We will discuss in next video. Thank you very much.